Good evening, everybody. Welcome to tonight's edition of Shop Talk, hosted by the Triangle Area SQL Server Users Group. So tonight, we had a last-minute substitution, tag out and tag in, sort of like wrestling. So I guess we are a three-person tag team tonight. Along with me, we have Tracy Baggiano. How you doing, Tracy?
Doing good. How's everybody else?
It's been a minute. Been a minute since we've seen you. Tracy is broadcasting from the nether dimension, where if you see ghosts in the background, you'll understand why. Yeah, you can kind of see the ghosts as it is.
Got to purge your recycle bin.
And forming the trio of terror, we have Mike Christensen.
Hello, everybody. Happy Monday.
So Shop Talk, in case this is your first time, this is a laid-back Q&A style discussion show hosted by TriPass. And usually we take audience questions. We give audience answers. Sometimes audience gives answers. Sometimes those answers may be better than our answers. Sometimes I get jealous of that. But usually I try not to let it show. I don't know. I was going to go somewhere else, but that was probably about as far as I wanted to go on that train. But if you do have questions, put them in chat. Otherwise, I have to go off of what's on my show notes. And so let's start with that. A couple of show note items. First, we talked about this last time around, but SQL Bits is coming up. So SQL Bits is a paid conference. Are you speaking, Tracy?
Yes, 2 times.
There you go. Tracy is speaking twice, making up for my not speaking there.
There we go.
I did speak
making
there.
Up for Kevin's slackness.
Yeah, I did speak at Bits last year remotely, but so you can register
I'm going
for.
in person.
Are you going in person this year?
Yep.
There you go. So if you're gonna be in the London area in March, you can see Tracy.
Yep, come see me on Friday and Saturday in a session, or just in general somewhere on Thursday, Friday, and Saturday.
Or you could also register and attend virtually. All the sessions will be online as well. That is a paid conference. Just to let you know, there's no free ticket even for virtual sessions. Speaking of paid conferences, the Dev Intersection / AI Azure Conference / Azure and SQL Server Database Conference is coming up as well. That one is in April in Las Vegas. I will be there and presenting a couple sessions. And if you use the discount code AzureDC, that will get you $100 off of your registration. So you could check that one out. That doesn't get our user group any money, but if you're going, save $100. I did actually run into a friend of the user group, Doug Klein, down there. Apparently, Doug goes to Dev Intersection pretty frequently, so I had to go to Las Vegas to meet a buddy from Wilmington. That's how life works sometimes. But if you're going, let me know. And we might see each other. It's, Vegas is a big city, but we're all in the same hotels, basically.
I've been wanting to buy.
Oh, go ahead, Mike.
This is my chance to buy a pop-up trailer. I've been wanting to buy one so I can take it and go out to Vegas.
That's an option. Paul Turley has gone to the RV life and is blogging about it. So we had Paul speak for the user group recently, and he's been on the road. He was in coastal California last time when he was presenting with us. But did a little travel. There's a few other people in the community who have RVs who do a lot of on the road life. Kellen Povan Gorman has been in that life for a while. She and her husband. So you could be like that, Mike. That's an option.
Yeah, we got connections. We can hook you up with Kellen. She can tell you all about it. Give you tips.
I love
Yep.
that. Yeah, I've been taking Brent's course, and he's got a good lifestyle. He has some different places he goes to. I got to
Yeah,
get in on
yeah.
this.
That is true. Being able to, like, oh, I'm gonna go to Cabo for a while. You know what? You can pull that off. Good on you.
I got to learn execution plans for real.
That's an important thing to know. If you don't know execution plans,
No
learn a bit
Cabo.
about them. And ask questions in chat as well, because we might know a thing or two about execution plans. Maybe 3, but that might be stretching. So we have one main topic of discussion, and then we're going to talk about another topic if we get to that point. But our main topic for tonight comes from a little bit of riffing off of a comment that Mike remembered from a decade ago. And, you know, in some respects, it's not fair to dunk on things people said a decade ago. In other respects, we do need content. So this is apparently old reactions stream night. But I think it's actually, let's not mention who it was, what the exact details were, because that's not really the point. And it's not, let's go laugh at this wrong prediction this person had or anything like that. Instead, we're going to take this a more positive spin. And the idea was, this was back in about 2013 or so, that relational databases are a lot slower than column store. And Mike, you mentioned 10 to 50 times slower.
Mm-hmm.
And that traditional relational databases would start to disappear soon, be replaced with column store databases like Cassandra or React, databases along those lines. You might tie in the document style databases of MongoDB or DynamoDB, Cosmos, but those things would effectively replace relational databases. And here we are coming back from the future to say that absolutely did not happen. React, one of the prime examples of that, technically the product is still around. They went commercial. Basho took them commercial, took them IPO, ended up tied up in one customer. It was a big customer, but that was basically their only customer, who pulled him into doing time series stuff that literally nobody else wanted. And they end up going bankrupt. React is now, I believe, still available open source, but the number of companies I've ever seen use React is 1. And that use case made it to about 2015 or so before it got pulled away. That's anecdote, admittedly, but I don't see React as a major player. Cassandra, interesting technology. That is still around. It's also not exactly taken off in the sense of all warehouses have been replaced with this, or all databases have been replaced with this. And I think it's fair to say that's never going to happen. I know never say never, but I'm going to say never here because it's not going to happen. Let's talk a little bit about why. Get an idea for where different data structures can fit in the world, because I think there is room for Cassandra. I think there is room for MongoDB or Cosmos DB or DynamoDB. I think there is room for Redis, for Memcache, for Aerospike, for dozens and dozens of different non-relational database technologies, but they're not going to replace the relational database. And so let's talk a little bit about how things work. And I will preface this by saying I'm not going to be able to give you detailed insights into the internals of Cassandra. My experience with that is, my latest experience was probably about a couple years ago, and it was at a very small level. Mostly it was, could I get it to work with Polybase? And the answer was yes, I could get it to work with Polybase. But I didn't really go much deeper than that. Which means I'm not going to be able to give you detailed like comparisons of, well, here's differences in language, here's differences in performance across similar workloads. Instead, I'll keep it at a fairly high level. We'll talk a little architecture. We'll talk a little about the fundamentals of columnar storage. And we'll see, well, relational databases have adopted a lot of this stuff. And I think that's a big part of the synthesis of thesis and antithesis there. And I'm now going to become very angry because I implicitly positively cited Hegel on something, and that's not at all in my repertoire. Behind my green screen, I have a I hate Hegel banner. I'm not going to show it to you because then I'd have to take down my green screen, but you can just imagine it's there. I imagine it's there every day.
Catherine
Speaking of which,
Hegel?
now I'm going to need to get a banner. I think Solomon's in chat. Solomon may appreciate my sassing of Hegel. But all right, let's talk a little column store. And in order to understand column store, I'm going to start with how classic relational database indexing works and the concept of row store. So we have data stored in pages in SQL Server. We have data that's stored on disk in Oracle and Postgres and other platforms in a similar fashion. Schrodinger's banner, a little bit. It exists in my mind, and there's a Hegelian statement in there as well, but we're not going there. We are not going there. We may go to Husserl, but we're not going to Hegel. Data stored in a row format, meaning I have all of the attributes of an entity stored roughly contiguously when written out. I have to say roughly contiguously because we can posit that the specific way in which data is stored on disk is abstracted away from the way that relational databases necessarily have to behave. And this actually kind of leads to a later point, which is really important. But if you want to imagine real easy database, I open up Notepad, my extra easy database, and I start typing, and I have delimited fields. And so I'm storing my data, writing it attribute by attribute per row. And we're reading the data per row, collecting those attributes, processing that information, and displaying those attributes. This tends to work extremely well in practice because typically we are interested in things at a row level, especially when we're dealing with a certain class of systems. The transactional processing world is driven by row-based operations because I need to get
observations and statistics, right?
Well, statistics is where things get a little different, where things get a little tricky. But think about order processing. A new order comes in. An order is its own entity. It has certain attributes on it. Now, we may have several order lines, but each order line is its own entity with several attributes on it. And if I need to display that order on a page, let me go retrieve it from the orders table, and I will get that specific entity whose key I have and represents some physical order, and I'm going to display those details on the page. So we tend to read and write one or a small number of elements at a time. This is the way that transactional processing systems have operated and continue to operate. That row style, row format, row storage is the classic behavior for databases. And Mike asks, what about Kafka based on your last statement about the transactional world? Kafka is its own interesting machine. It's its own interesting process. I am a big fan of Apache Kafka. I really like event-driven systems, and you can even in my Matter days, you can get me to agree that Kappa architecture is really cool. Is Kafka paradigm breaking? Not really. It is a very useful technology. It is a key part of a lot of high scale, high throughput systems. It still fits into a broader event-driven world. So I like the technology a lot. I like the concept that broker-based essentially logs of event data, and I think that it is incredibly useful for certain processes. But really, if you want to think about it, go all big brain on us. Kafka is a transaction log that you never delete. So Kafka is like if I had my SQL Server transaction log and I never truncated it. I'll let that simmer for a moment. Stream of messages from nodes in a network. Yeah, it's very useful for wide-scale distributed processing, and also being able to replay technology, this system over a period of time, and I find that really useful. But I think it still plays in the same space. It doesn't really centralize the data, right? It does across your cluster, and your cluster is usually going to be in the same physical location. You typically don't want a Kafka cluster that's geographically distributed, because the different nodes have to synchronize with each other, and so you're going to want that to be pretty close. It doesn't have to be on the same rack, but you're going to want it in the same data center. If you have widespread distributed Kafka, what happens is you have so much network latency, you have so much network traffic that it's not going to scale it out. Ties in well with Spark and the general Hadoop ecosystem, yes. And again, in those cases, generally our scale out is still within the same physical location. We're not talking about global scale, global distribution. Generally, you can get to that using essentially replication between clusters, but you don't want your cluster to have one node in North Carolina and one in Mozambique. That's going to be really bad for any type of performance. So let's get back to row store. Again, I'm keeping things incredibly simplified. The actual implementations of things are a lot more complicated than what we're talking about. But you store your data a row at a time. When it comes time to process, I page through, find the row. I say, yep, that's the row that I need. Return the row. There are techniques that have been developed over time with, for example, B-tree processing, where I can jump through to a couple of different levels in order to find my particular row. So I don't have to scan through the entire Notepad document. Instead, I can parse through it very quickly and get to the row that I need. But generally, we're talking typically about reading rows of data. Now, Mike mentioned statistics, observations, and this is where things get a little bit more complicated for the database story. And that is when you have analytics analytical processing. Generally, you're not as interested in an individual row as you are a collection of values for a particular column or for a set of columns. So, as an example, we have orders. And for a transactional system, I care about the order. We're looking up an order. When I'm concerned about analytics, I may be concerned about revenue, cost, shipping, revenue, shipping costs, tax costs, and product costs, merchandising costs for a set of products in a distribution center in a geographical region. And I want to aggregate that detailed information, maybe break it out by day or by quarter, and then return a report. So I may have potentially a very large number of rows I need to process. I need to filter them down based on the criteria I have set, and I need to aggregate a few measures. Well, transactional systems are going to behave the same way as I just described. You basically have go down, find a row, or scan through and maybe scan a whole set of things. If you happen to scan and it's a roughly contiguous scan with what I need to get, and I don't have that many columns, then this can be very efficient. We've had warehouses in relational database technologies for decades. The Kimball model is built on this principle. We build out fact tables, we build out dimension tables, and that Kimball model is really based on using relational databases for this work. But there is a performance hit. That performance hit comes in your fact table when you have a wide number of columns, and you really only need a couple of them. And this is where column store style products came into play. This is where a product like Cassandra made available the idea that, well, what if instead of storing every row individually, we actually store data by column? And this is a smart idea. So smart that two of the most common file formats in the big data space, Orc and Parquet, are both based on this general concept. Instead of storing your data as rows with individual attributes, you store them as columns, and you have an ability, like it's essentially here is my row ID and the column's value, row ID, column value. And that way, if I need to get all of the elements, I can. But usually what I'm interested in is, here is the column value, here is an aggregation of them, and I can very easily perform whatever aggregations I need to on this data after filtering it. This leads to a lot better compression, much better performance on aggregations, and much worse performance if I need to get a bunch of small rows, but I need to get all of the attributes for them. So we have a trade-off here. We have two separate use cases, each of which has an optimal physical layout. The optimal physical layout for the transactional world, I'm storing rows of data. I collect all of the attributes together with that row, or at least together in an abstract sense. It doesn't have to be all on the same page. It doesn't have to be in the same location on disk. They can be in different places, but conceptually together. Versus columnar data, where I'm storing the columns together, but individual columns, so all of the contents of a column together, but individual columns don't necessarily have to be right next to each other. They don't have to be contiguous, because I'm not necessarily going to get the next column like I am if I'm collecting data per row. Per row, I generally want to get all of the columns here, or some large enough subset of the columns. All right. So I've just said there's room. This town is big enough for the both of us, basically. There is room for Columnar. There is room for Row Store. And if you go back to 2013, I think that's an important year. Really, 2011 is probably a better year to make this claim. But 2013 is it's fair to point out that if you were trying to perform analytical style data, if you were trying or perform analytical style queries, you have a warehouse, you want to aggregate columns, you want to perform fairly simple operations. Well, if you're using a relational database, you're not necessarily going to get you're not going to have a good time necessarily. You can do it. Oracle, SQL Server, they have, or Postgres or whoever, they have database engine optimizations that are intended for this type of warehouse style, this type of analytical query. We have SQL Server optimizations going back to 2000, things like merry-go-round scans that you can see people have put into place. We're trying to make these big, broad queries faster. But what you end up with is still trying to shoehorn this row store style into a tougher columnar problem. And so the products that are out there, the Cassandras of the world, the React of the world, try to solve two separate issues. One is I can store the data in a columnar fashion, query it directly as columns, and perform aggregations that will be much faster. Two is I can have multiple machines working together in unison and take advantage of scaling out, the distribution of scaling out. So React and Cassandra both, you can set up multiple servers. You can have multiple machines working together in a cluster and have those clusters work on problems concurrently. That way you can scale out a problem and have multiple machines aggregating certain subsets of the data, returning the full result back to you. When you're working with extremely large data sets, that can make a significant difference. If you're working with millions of rows, tens of millions of rows, hundreds of millions of rows, maybe not as big of a difference. Mm-hmm. I mean, one good machine can do a lot there. But if we're talking tens of billions of rows, then we may be looking at something interesting here. It may be worth distributing it out. And in the context of that statement from 2013, I can understand why a person might say, oh, well, the traditional database is going to disappear. I still would have disagreed with it in 2013, but you could say, if you want to be really pedantic about it, the traditional database is not what it was back in 2013. If you look at SQL Server as my example of choice, because that's the one I know best, the reason 2013 is not the best year to pick this is 2012 introduced column store indexes. Now, SQL Server 2012's column store indexes were garbage. They were non-clustered only, they were read-only, and they didn't really provide much in the way of performance benefit. You couldn't put it on a fact table effectively. If you put it on a table, you couldn't modify. Like I said, they're read-only. And so there's never a great fit. You still had to have a clustered index on your table. This was non-clustered indexes only, and the performance just wasn't that great. However, 2014 introduced clustered indexes, clustered column store indexes that were writable. 2016 made significant performance improvements in terms of how clustered column store indexes worked behind the scenes, in terms of populating row groups and not leaving you with tens of thousands of tiny row groups. And there have been further improvements in 2017, 2019 with batch mode processing. Mm-hmm. In other words, the analytical style of operation, we create a clustered column store index in SQL Server and replicate a large portion of what that columnar database or columnar structure gives you as a benefit. So with SQL Server Column Store, we are storing columns as the key point in data. And if you really dig into the internals, essentially, if I remember right, a row group has basically one row of var binary data per column, and that var binary data collapses together all of the information about that column in a compressed format. It's real interesting to dive into to see how it's done in a database platform that is essentially row store, but performance tends to be extremely good. And by combining the collapsed row store, the compressed columnar storage, with a row store based Delta store, where I have rows that are sitting there until they get packed in a final process, we get a nice benefit of I can still write, I can still insert new rows, and we'll let the compaction and processing happen behind the scenes. And as I query it, it's still just a table to me. I use the same T-SQL, I use the same syntax, all of the same applications can query this table because it's just a table. This was one of the pain points when going over to a different platform, whether that had been React or Cassandra or I'm trying to remember what the third one was, Couch DB at that time. Yeah, I wanted to say Couchbase, but that's a different product. So when looking at those, they have this same general structure, and they all have kind of a SQL-like syntax, but it's not the same ANSI SQL. There are differences. There are big differences in terms of what that syntax looks like. And so there is a learning curve in switching over between using SQL Server's T-SQL or Oracle's PLSQL, Postgres PSQL, to using the React, I forget what React called it, or Cassandra had their like CQL, where you could still write SQL statements, kind of. You just couldn't join. So you had essentially select queries with aggregations on it. And there's a learning curve. There's the fact that things are in different products. And if I want to take data that's stored in this system and use it to filter data stored in this system, things tend to be really slow compared to if they're all in one system together. Final result, we end up with these data platforms and making it very difficult to justify having multiple data platforms, especially when the main data platform starts to include some of the capabilities that are really beneficial for your other platform. And if I wanted to go even a step further, we could talk about dedicated SQL pools in Azure Synapse Analytics, which give you that massive parallel processing, that scale out, that Cassandra, that React, and other technologies along those lines, or even document databases like a MongoDB or Cosmos DB or DynamoDB. Those scale out capabilities within the rough world of SQL Server. It's not really SQL Server. It's a different beast. It is different, but close enough that the learning curve is a lot shallower than if you were going to take on a brand new platform and really understand how it works.
So I had brought this up because I was very fascinated by it, because what you're telling me is absolutely wonderful, because so in listening to this person talk about 2013, it's good to hear you say 2011, 2013, that the column store were super more performant than the traditional options at the time. And you're saying, well, there's some additional features that were created 2012 and later that made it more competitive. So the 50x thing, not true anymore. I had also understood that, it was an advantage of the column store to have like more of the traditional SQL syntax where you have millions of, you know, assets out in the world who know SQL, right? Learning a new thing is always a challenge. So you could have a really good technology that just is at the wrong time and it's not going to get any traction because you don't have the expertise out there. Because I had told you outside of the stream that one of my colleagues and friends, they had used one of these products and then backed out of it because it had not gone well and there was a misunderstanding on how to use it and maybe it wasn't designed very well. So anyway, I really appreciate the expertise in explaining kind of column store because I had not, I've heard of it. I've been learning more about some other technologies and it was fascinating to kind of, I was listening to these experts and then I went back to this original thing that was recommended, and it's fascinating to like listen to something from 2013 to today because there's a lot of things that I learned from 2012, 2013, 2014 that still are persistent today that are valuable to learn. And this was new. So, and the prediction that was made from somebody who is a absolute expert didn't come true. And it's fascinating to hear your perspective on it.
Yeah. So on the topic of SQL-like languages, actually, I have a blog post from 2017, Fiesel's Law. The rough summation of Fiesel's Law is every data platform technology, as it matures, eventually develops a SQL interface. And the reason for that, I mean, it is tongue-in-cheek, but the reason why it's effectively true is that people are so used to writing SQL. SQL is a really good language for data. It's a domain-specific language for working with data, and on the whole, it is really good. You can make arguments that it could be better, like having the from clause come before the select clause. That is backwards in terms of processing, but conceptually, it is close enough to English that people can read it. There's not a lot of symbolic nature of language in the syntax, in the grammar, and it's pretty straightforward in how things operate once you have some understanding of how it works. So the learning curve for people who are not developers tends to be not as steep. Ironically, a lot of developers think it's way too hard of a language, but you can effectively write code in Java, in C# and Python. You can write code in SQL. It's a different mindset, but the syntax of the language, I think, is pretty simple. So Fiesel's Law makes sense here because you have such a broad base of people who already know SQL that when a new platform comes out, the first thing they ask is, okay, well, how do I query it? How do I write SQL statements? How do I query it? This is where, for example, as Hadoop started taking off, one of the first major improvements on Hadoop was Hive, warehousing in Hadoop. It's SQL on Hadoop. And that was a product that Facebook put out within roughly 1 year of the first public release of Hadoop from Yahoo. Even on HBase, which is a non-relational database that lives in the Hadoop ecosystem, you have Phoenix, which is a SQL interface for your non-SQL database. Because people would rather write a SQL statement than have to learn another data processing language.
Well, yeah.
So Mike asks, how did Cassandra's consensus model and other distributed systems with guaranteed consistency, and here's scare quotes, guaranteed consistency, work in terms of column versus row efficiency? And isn't a NoSQL record more in line with distributed technologies? Wouldn't that be a big NoSQL versus SQL difference? All right, unpacking some of these questions. The consensus model in distributed systems, guarantee of consistency is optimistic in many cases, and looks like Mike has been kidnapped by ninjas as well. They must have knocked at his door too. So, especially in the early days, guarantees of consistency were not worth the paper they were written on. And MongoDB is the whipping boy for inconsistent consistency, where strong consistency meant I was strongly certain that you were going to lose some data. This is where you had the Jepsen system. And I'm going to drop a link to Jepsen in here because even though it's been a few years, and a lot of these articles are, in fact, kind of, they're no longer looking at current versions of different platforms. I think it was incredibly interesting to learn about how all of this works. And essentially, Jepsen was a very simple concept. It was, okay, I'm going to start writing records and I'm going to purposefully trash nodes on your system. And how effectively are you going to bring back the original data that I wrote as I'm trashing your nodes? The more consistent your platform is, the fewer disagreement there would be between what I originally put in and what you're giving me back out. But Jira has JQL. Yeah, Jira does have JQL. And even a lot of data platform things that are totally unrelated to SQL databases still have a SQL interface. But if you go back and look at some of these old Jepsen articles, he was a good writer. Kyle's a good writer, and very interesting in terms of diving into the weeds on how the different models worked. And he looked at a whole bunch of different products. There's at least a couple dozen on here. And again, many of these products, as a result of this research, have fixed many of the bugs that were in there. Like MongoDB, there are actually 5 separate analyses of MongoDB. And the first ones are savage. I mean, they are really brutal. Later ones, they fixed a lot of the problems. And I do give them credit in that regard. So guaranteeing consistency has always been kind of a roll of the dice, unless you had something like React and CRDTs. This was ironically one of the things that made React a really good technology. The conflict-free resolution data type. Essentially, the idea was if ever there was any sort of conflict between two objects, I could use this mechanism to guarantee that this piece of information is newer than this piece of information, and therefore I need to use this one, versus a standard wall clock based approach where here is my timestamp. This has a timestamp of X. This has a timestamp of Y. Let me compare timestamps. The reason that doesn't work is if this clock is ahead of this clock by enough, this record may actually be older. It may have been inserted first, but that clock is further ahead. And therefore, when we compare timestamps, we say, oh, well, this is the newer version, when really it's the older version. Also, if you do timestamps as in incrementing, this is version 1, version 2, version 3. If I have version 3 that was accepted on this node and version 3 that was accepted on this node at approximately the same time, how they merge together and give me a true version 3 is a challenge. And CRDTs are a construct. They're actually very difficult to pull off in practice, which would allow you to very easily say, based on the contents of the data, I know that this is newer than this. And if you had something like a number that was generated, you could always say higher number wins. But a lot of problems with implementing. You know, like Mike says here, devil's in the details. And that was true with CRDTs. It was a very complex topic. Getting it to work well in practice was a challenge. But conceptually, that is your way to have a distributed system where you can guarantee consistency. Otherwise, consistency guarantees in distributed systems are provisional. Okay, so that was my little cul-de-sac on consistency. Now, how does that work with respect to columnar versus row-based efficiency? You could say that row-based, so distributed systems tend to work a little bit better with row-based data if you're talking about insertion, and columnar data if you're talking about query access. It's the same as a single system, which is why we have in the Hadoop world, we've got Avro and we've got Parquet and Orc. Avro is a row-based file storage mechanism, and Avro tends to be very efficient for transactional style processing that happens in Hadoop. If we're using something like HBase, where we're constantly writing out changes to records, or where we're using Kafka, where you're writing out a stream of events, you're storing that data essentially row-based. Technically, you could say technically it's key value, but you have your key and your value together. And it is essentially row-based key value storage. When it comes time to analyze, to aggregate that data, this is where, that's going to get us banned from Twitch. Cat nudity. But now that the cat has completely thrown me off. So when it comes time to analyze that data, the most efficient mechanism for analyzing that is still columnar storage, regardless of whether one machine is doing the work or 60 machines are doing the work or 6,000 machines are doing the work. That's something that actually tends to be constant, regardless of number of machines working on the thing. Now, whether or not a different technology, a document storage technology, is more in line with distributed technologies than a classic page-based database, maybe. But at the same time, like I mentioned, SQL Server allows for distributed processing using APS on premises, which I can never afford to look at, much less own, and dedicated SQL pools in Azure Synapse Analytics. So I have here a concrete example of this is SQL Server running on anywhere from 1 to 60 machines. And as a developer, I don't have to care about how many machines it's running on. It just works the same way. Document-based storage is typically a more commonly split out data style, but I work in an environment where with on-premises SQL Server where we've broken out data across dozens of SQL Server instances, hundreds of databases, and it's not that big of a deal. The specifics about individual records and how things get accessed and how things are processed, it is going to be quite different. It's not like you have a cluster of 20 SQL Server instances that are all interacting with one another and sharing details on transaction log data in order to allow for scale out processing. So that is a difference. That is something that you're going to find in a MongoDB that will be much, much harder to do in a traditional relational environment. But smart people do a lot of interesting things with both types of platforms. And so I don't know that what you were driving at, or if you were driving at something in particular, I'm not sure I fully agree with. Okay, for the newbie like me, if we ignore efficiency, will the end result ever be different based on row versus column store in distributed tech? Short answer, should be not. So your data, if you ignore efficiency in terms of write performance, in terms of read performance, your data should be the same. You're going to write the same, you're going to read the same. This assumes that there are no bugs. This assumes that you're not going to have the problems of distributed systems like network issues leading to split brain problems. And regardless, usually when you're writing into a columnar store, usually you have a Delta store. And that Delta store in the SQL Server world, Delta store is essentially a table with no indexes. It's a heap. And it's row store. And it's a parking lot for holding data until you have enough of it that it makes sense to put it into a column group. When you're writing into Cassandra, I'm going to have to defer on giving any specifics about that. So I don't know enough about that to be able to say for sure if they have a temporary holding zone that's row storage based and then it turns to columnar, or if they do write it out directly columnar. I'm not sure on that answer, but neither one should in that theoretical world make more mistakes. In the practical world, you're going to have more problems in distributed processing systems than you will with single servers. That's just general fact of life. You have more things that can go wrong. You have more things that will go wrong. And there are algorithms in place that can reduce the likelihood of an error. You have error checking. You have writing to multiple nodes and having those nodes compare notes. Basically, here's a hash of what I wrote versus here's a hash of what I wrote. And if there's any sort of disagreement, then there are mechanisms in place to try to resolve those issues. You have, ways of trying to deal with these sorts of problems, but they will exist. Those problems will be there with any sort of distributed database. So yes, it is much harder. I completely agree. It's also a thing where I'd say make sure you really need it before you dive into it, because it is harder. It is harder to manage. It is harder to administrate, and it is to administer. And it is also going to be harder to deal with problems, except for corruption of single server. Yeah. And I'm not going to say, single server is a panacea, that it's a perfect solution. That's why we take backups. It's why we have processes to check for data corruption. In SQL Server, you have CheckDB. So I'm checking to see if there are any issues with the data. And we have systems to perform these checks. We keep histories of our data. We keep those backups and have the ability to restore them later. We keep those backups off the server because servers blow up. Servers catch on fire. Servers get caught in rain downpours that break through a roof and end up leaking onto that rack and destroying a whole bunch of servers in the process. That's happened. Thankfully, I was not one of the administrators who had to go into the data center and try to get that sorted out, but that was a fun time. So that stuff does happen as well, yeah. And that's where potentially a distributed system could be of assistance if you have enough servers that are not on the same rack that got flooded. But if your data center gets nuked, distributed systems tend not to recover very well from that. Not unless you have replication out to a different place, and in which case I say, well, your single SQL Server or Oracle instance can also replicate out to a remote location.
You just need RAID 5, right? That's a joke.
Oh, okay. I wasn't sure how to take that one, right?
Yeah, no.
And ECC and other memory detecting technology of corruption. Yeah. Having modern memory with error control saves so many problems over the long run. It's more expensive, but that is a no-brainer for me. I would gladly pay the 2x price or whatever it is for quality error checking, because that's going to save you over time.
Tell Intel.
Can't someone make a single long distance part of the distributed database such that they survive the nuke? The short answer is yes, but it'd be roughly the same technologies and with roughly the same positives and drawbacks that you would have for a non-distributed database. When you think about a SQL Server instance, we have disaster recovery. We have it in the idea of log shipping. So I can take those transaction logs and just keep shipping them over to another server across the world, and that would survive a nuke. We have distributed availability groups where I'm sending transactions. Again, basically sending the transaction log to somewhere else in the world. In Hadoop, like you mentioned, yeah, you ship everything. So you have your Hadoop cluster, which is in one area, and you may have certain nodes. You have your edge node that is going to be also writing out to some other remote location. So I may have my data stored on these machines. I have these racks that have storage, and I'm also shipping it out someplace else. The tricky part there is when you start talking about extreme levels of data where you're talking petabytes of data, the ability to ship that someplace gets a lot more challenging. Your bandwidth, even if you have gigabit bandwidth, that's going to take approximately forever to ship over petabytes worth of data, especially if you have frequently updating data. So in practice, that's a real challenge. Getting a extreme scale, extremely large amount of data, guaranteeing that I have multiple good copies of it in physically separate locations. Actually, that may be at the point where you say, this is where I have somebody come in with a truck, and you dump a bunch of hard drives in a truck, and you drive it out to the other place. That may actually be faster in terms of getting your data over. It is very high latency, but it is extremely high throughput. So do smart people put their backup disks and tapes in a truck? Iron Mountain. Yeah, I mean, yes, that's still a thing. It's going to depend on the data. It's going to depend on where you're working. Government agencies are probably much more likely to have physical off storage someplace safe in a vault somewhere. In a lot of cases for companies today, our backup is often, let's put it in S3, let's put it in blob storage, and take advantage of data being distributed there. I mean, I can have data distributed in blob storage in multiple regions, clicking a button. I want zone redundant storage. I'm paying extra for zone redundant, but what that means is I'm storing data in East US and West US, and I'm not doing anything about it. It just gets there. There are similar options in S3 for AWS. There are similar options in Google, and that's taken a lot of the classic Iron Mountain style of job away, because now I don't necessarily need to put it on tape. I can just put it in the cloud, get it back out. It's usually cheaper. It's usually faster. But the physical location is still available, and you can still use those types of services, especially if you have data that you don't necessarily want to be in a cloud, or that for legal regulatory reasons you can't put in a cloud. Sorry to hijack. No, this is the point of shop talk. And actually, speaking of the point of shop talk, we have basically hit our end of day. So on behalf of Tracy and Mike, who once again have been kidnapped by ninjas. Mike rescued himself a little while ago, but got kidnapped again. Oh,
Oh,
there's
no,
Mike.
no. Data is my life. Get out of here.
So, on that note, now that Mike has rescued himself from those ninjas, Tracy, I'm sure, will eventually extricate herself. And I want to say thank you so much. We hope to see you again. Remember, next Tuesday, we have our advanced DBA meeting. Karen Lopez is going to be talking about blockchain for the DBA. And so stop on by for that. And in the meantime, everyone have a wonderful evening.
Good night.